everyone, welcome back to this part3 channel. Now we have to check about the release from the previous tutorial, and we have to make sure your release is correct with your concept. And now I have to have a spot check in the column. We do not have release. Okay, we continue, it's correct. And for the purlin, we release is in one rotation. Okay, you cannot release it in two rotation, because you release into rotation about y and z axis. This system will be unstable. Okay, now you have to check for the pressing. Okay, you can check here for the pressing. We release is to make it for the truss structure. Okay, and this is the same, and we also release the torsion in one direction. And for the L section, you see here it is a L section. Okay, L section, and we release for both direction. Okay, it is a pin connection now. Okay, and for diagonal, for the 3D frame, and to make sure our structure is stable, we have to keep it in the continuous. Okay, and this section can receive moment, some bending moment, and actual force. Okay, now everything is correct with our concept. And after you run analysis, you can check about the moment in the envelope. What is your structure is now I have to run it again. You have to make sure your structure has no error, and check and analysis again, check to fetch which part that error. We want to talk a little bit about this, and we will continue to comparison between the frame and portal, single portal frame, by using hollow section condition. And what is different? We compare the two models in terms of economic, and you can check the diagnostic, no other result error, and you can check the further analysis and check for the envelope ultimate mistake combination, and you can check for the end. And now we can focus about the moment. Okay, you can see here your column can see for the moment, and you can increase it. Okay, and for the upper and lower chord also, this is some moment. Okay, and diagonal, this is a very little moment, bending moment. Okay, now we have to go forward to global check again. We check for the buckling is the same, and in this one we apply perform it, and after that we have to compare with the single portal frame in the previous tutorial. Okay, you see here from our previous tutorial, with the same span and the same height, it's the same geometry, and we use the same for the geometry, just different option. In the option we design for the portal frame, and now we have to check it. Okay, you can check it about I select for the load combination for the SLS. You can check here you have the combination for SLS or not. Load combination. Okay, you have for SLS, and you can check it in this term, or I have to run it again, and we check for the deflection. Okay, and like this you can check. I want to focus about the deflection. Serviceability, you can check here, is around 36 millimeter, and we compare it with the photo frame about deflection, strength ratio, global stability design, and the weight of the frame, and how much how many ton of the steel we use. Okay, now we have to check for the indicates. We have to check for the SLS. Where is SLS? First order combination 1, combination 2, SLS. I do not yet see SLS. Now we have to make sure SLS is included in our analysis. Okay, we have to check it. Okay, in this one and this one, and we check it for all. Okay, it's correct. Okay, now SLS we have to include it in our design for first order. Okay, you can check it for the deflection only. Now I have to run it again, and we want to compare about deflection. Okay, in terms of deflection. Okay, now we have to select for order and serviceability. Okay, file is the same. Now I have to take on this node and marker. Okay, and we have another node is marker, and add the another column in marker. Now we have to compare about the combination serviceability combination 5. You can see here the maximum value is 127 millimeter, but for the truss structure is only 36 millimeter. Okay, and the combination 6 is 27 millimeter, and this one for combination 6 is 97 millimeter. And now we have to continue to combination 7 is deflection in each direction is 76 millimeter, and this one is around 15. Okay, see here 15 with 75. Okay, in for the photo frame we use the column, the bigger column, and with the hole connection. Okay, this is well for the each direction. Okay, and we have to check about the deflection. You can see here the DZ vertical direction is 50, and for the truss is only 13. Okay, 13. So you can check the it is 37, and for the photo frame has a little horizontal deflection than the truss structure, but has higher vertical deflection than truss structure. Okay, Now you have to make sure everything we compare it the same concept, it the same structure, the span and base is the same. Okay, 34 6 meter and the height is similar. And now we have to check about the perform check, and this one we also check for the perform check, and we check it for the buckling also the same. Okay, and for this calculation we also perform for the buckling. Okay, you can see here the exchange value is lower than the portal frame for 1.92, but it is acceptable for our structure when you analyze this and perform design. Okay, it's around 2, and you can check for the portal frame has a higher exchange value than truss structure. And after that we have to compare the result. The result is around 100%. Okay, you can see here the exchange value is higher than our truss structure previous one. Around 2 is here 3.83. Okay, it's around 2 times. And you can check for the design is around 110 percentage, and our truss is in the column or in truss. Okay, in truss is around 100% in truss. Okay, in truss you can check here in truss, and for in column is around 92%. Okay, 92%. And finally we had to check about the total weight of the structure. And for the steel truss, the same geometry, and the total weight is 34 tons. Okay, 34 tons. You see here about section, you see here everything is 34 tons. And we had to compare with the portal frame using hot roll section, and how many tons we use. Okay, it's around 48. I round it to 49. You can calculate it the difference about this value. I have to copy it and pass it, and minus with the value in truss is 34.2. the unit is ton. Now we have to minus 34.2. So you see the difference is around 14.54 tons. And you will ask why it's different between design truss and design for the single portal frame hot roll section. Is the vertical deflection. For the truss is good in the vertical deflection, but before we use the column, it has a small section than a portal frame, single portal frame by hot roll section, so we have much deflection in horizontal deflection. And the design result for the truss frame is got better than in the portal frame. Okay, in this one when we use hot roll section, and now compare when you taper section. It is for the hot roll section, standard section with the hole connection. Okay, hole connection. You see your structure for the hole. The value is around 66 or 70%. You can issue the hole thickness, but when you issue the hole thickness, we will be effect on the column. Okay, the column and the hole, the result here will be increased more than 107%. So to make sure you have to increase your column again to receive the design value is lower than 1, or you have to add another pressing at the middle of column, but you have to check it when you apply the pressing to the shoe for the buckling. It affect on your structure or not. Sometimes when you apply it in the axis to axis analysis, the result is not change too much because the global stability control not local, okay, not local buckling on the column. Okay, thank you for your watching. Thank you for your support us. Now we just to compare, and you have any comment you can comment below. And the next step we have to compare with the taper frame and which one is more economic. We have to compare in terms of the section and the unit of the unit base of the frame, not compare for the erection time or fabrication in the warehouse. We have to control in the model. In the case we control only for the unit base or the model is what is different. Okay, don't have confused about the construction time. We have to focus only for the material. Okay, thank you for your watching. Thank you.